In section 14, we're going to continue to illustrate in greater detail how DRP signals cascade up the supply chain to overseas suppliers. And to begin to do that, we're going to bring back an old friend from previous slides, which talks about the integration, as we know, of the sell side of the supply chain with the buy side of the supply chain, bearing in mind that we're talking about finished goods in an omni-channel environment. Distribution requirements planning is about the location and quantities of goods at different distribution nodes within a U.S. distribution network. Although it's possible, it's not likely that a U.S. importer is going to distribute from one location. It can happen, but the larger an importer becomes, the more customers are spread out around the country, the more likely it is to have 2 DCs, 3 DCs. Really large companies could have a dozen distribution centers in the United States, especially when it comes to omni-channel distribution. Within that framework, DRP talks about having the right product in the right time in one of those locations. It could be a large regional DC that feeds into smaller satellite DCs in the northeastern United States, southwestern United States. In fact, our upcoming example does just that. But again, DRP is about the quantities and timing of finished goods in specific locations and what we'll call a multi-echelon distribution network. Just a fancy way of saying more than one DC. For sure, everything starts with a forecast of customer sales and actual demand signals that come in from our omni-channel network. Customers. The trick is, how does that information get into the distribution network? But for purposes of this entire module, how do we cascade up the supply chain to overseas suppliers in the form of a purchase order? That is the ultimate tie-in between the sell side and the buy side of our supply chain, with an underlying concept being, as it relates to DRP, how cumulative lead times impact those activities, taking into consideration all of the functions related to placing a purchase order. The vendor has to acknowledge the PO. The vendor has to go out and get raw materials, go into production, ship the goods. All of the elements of cumulative lead time that we've talked about, honestly, a million times. How does that tie into DRP? And not only the quantities that we have to order, but the timing of those orders. Hopefully, this visual portrayal helps to drive those overarching themes home. We can't do a supply chain perspective on why MRP matters to the purchasing function and not do one on why DRP matters to the purchasing function. Because once again, we here at Mercado like to be thorough. As we have stated on numerous occasions, DRP is conceptually similar to MRP in that it calculates the future needs for goods over a specific planning horizon, time phased as the terminology is used. Whereas MRP deals with raw materials and DRP is for finished goods, both are driven by the two key variables of timing and quantity. We can't say that enough. Since our interest has been on omni-channel importers of finished goods, DRP becomes particularly relevant because DRP calculations tell us when, where, and in what quantities we need to have finished goods positioned in order to meet both forecasted and actual demand. Here's the big point. When a global supply chain is viewed as an integrated whole, the buy side and the sell side, it is clear that DRP plays a major role in helping the purchasing department to determine the timing and quantities of its procurement activities with overseas vendors. Based on the concept of cumulative lead times, purchasing professionals have to calculate the timing and quantities of their purchase orders to sync up with the positioning of goods across a multi-facility or multi-echelon distribution network. Quantities are about the forecast and adjustments made based on actual demand. Timing is about cumulative lead times. Without DRP, as well as other tools, like sales and operations planning, for example, which we'll talk about in upcoming sections, purchasing would be challenged to meet the above goals. In the following section, we'll be looking at additional tools that aid in this endeavor. Before we do that, let's talk about DRP in the 21st century and then an actual example. Luckily, just like with MRP, all of the calculations that are continuously required for DRP can be automated through software. It can be part of a fully integrated DRP system or available as standalone DRP software. As both forecasted and real-time demand signals change, guess what? The DRP system automatically updates both gross and net requirements all the way up the supply chain, meaning to the creation of purchase orders. In turn, last bullet point, these updates trigger corresponding changes in the purchase orders placed by finished goods importers on overseas suppliers. That's the whole trick right there. Let's illustrate it a little bit further. We have a real-world example, albeit simplified, but it's for DRP for a footwear importer that uses a multi-echelon DC model, meaning they have more than one DC in their network. The following slide illustrates a DRP record for an importer and distributor of women's footwear. It is important to note that the importer operates two primary DCs in the U.S., one in Sparks, Nevada, which is right over the border from California, and another in Memphis, Tennessee. Big regional DCs, along with smaller satellite DCs in Dallas, Chicago, and Boston. Not an unusual setup in the United States. The item record under analysis, looking at a specific item, a specific model of footwear, is for the distribution center in Boston. As such, our analysis starts with the Massachusetts DC, cascades back to the Memphis primary DC, where the Boston satellite is going to receive its goods, but then from the Memphis primary DC, the demand signals have to go all the way back up the supply chain to the vendor, who happens to be in Cambodia. The DRP record under analysis is an admittedly simplified illustration. For example, it does not take into consideration safety stock or any time buckets in which the Boston DC will run out of this particular item. And we all know out in the real world, runouts happen all the time. With that said, the example clearly demonstrates the importance of gross to net exploding, lead time offsetting, and projected on-hand calculations to management of a global supply chain. Ultimately, the purpose of this exercise is to be able to cascade DRP information all the way back up the supply chain to the actual vendor in Cambodia, taking into consideration not just the lead time from the primary DC in Memphis to Boston, but the cumulative lead time of the product all the way from Cambodia. Clearly, purchasing plays a huge role in this because they're the ones that have to place the POs on the Cambodian vendor to make sure the stuff not only gets to Sparks, Nevada and Memphis, Tennessee, but also to Dallas, Chicago, and Boston. Based on what? Forecasted demand and adjustments based on actual demand. Let's have a look at this record for a single item, single model of footwear. Our title, of course, DRP for footwear in a multi-echelon DC model, what we just described. Before we get into the numbers, let's look at the left-hand side of this slide, starting with periods that go from left to right. These are the time buckets, 1, 2, 3, 4, of 1 week. We're isolating 8 weeks, obviously would have to engage in a 52-week exercise to capture the entire planning horizon. Below that, gross requirements. This is an example of one of those oversimplifications we spoke of a moment ago, because the gross requirement is based on a forecasted amount of 300 units for this particular model of shoe across the 8 periods. Out in the real world, it's not likely that it would be 300, especially if there was seasonality or planned promotions built into this. It's just for simplification purposes. The big item we're looking at, and this is for the Boston satellite DC. What is the projected on hand, POH, as we see on the left, in each period? That's the big item we're looking for. Are we going to have enough of this shoe to meet demand in each period? And if we're not, what adjustments can we make to make sure that we do? Or if we're going to have too much projected on hand, what can we do to back off some of those purchase orders that might be out there on the Cambodian vendor? Projected on hand is a big deal. Planned order receipts as well. Those are actual receipts from the Memphis DC that we're planning on receiving because we already placed orders on that Memphis DC. From a purchasing perspective, that information has to get from Boston to Memphis all the way to purchasing, and purchasing use that info for future purchase orders on the Cambodian vendor. That's the whole idea here. And then, based on the depletion of goods in each period, the sale of goods in each period, DRP software is going to give us planned order releases, telling us out in the future, based on what's going on right now, we had better plan on additional orders being released. For the Boston DC, that order release is to the Memphis DC. But again, that information has to get all the way up the supply chain through purchasing up to the Cambodian vendor. We're about to jump into the numbers, but very lower left-hand side, very important to note that when the period begins, on hand, we already have 1,300 pairs of this particular model. Lead time period, 2 weeks. Now, one might say, well, why would it take 2 weeks to get an order from the Memphis DC to the Boston satellite DC? Because that's what we're talking about here in terms of a period. That's not cumulative lead time. It's the lead time from the Memphis DC to the Boston DC. Again, this is for illustrative purposes. We can question that at a different time. And then the order quantity has been determined to be 1,000. So when an order is placed on the Memphis DC by the Boston satellite, they're going to get 1,000. There's lots of reasons why it might be 1,000. We're not too concerned with that right now. For purposes of this illustration, it's 1,000 units. Okay, let's get into it. Gross requirements, as we said, 300 across the board for simplification purposes. As we begin, we have 1,300 pairs of this shoe on hand already. So in the first period, the projected on hand after the period is over at the end of that week is going to be 1,000. Why is that? Because we had 1,300 to begin with. We're going to sell, hopefully, 300 of them. That leaves us with a projected on hand of 1,000. As we move into the second period, it's another 300, now being depleted from the previous time buckets on hand of 1,000. That's why we're showing 700. However, right below that, we can see that the system is telling us that in order to not run out in future periods, and based on the forecast of 300 pair per week being sold out of the Boston DC, we have a planned order release of 1,000 pairs. An order release on the Memphis DC. That's a planned order release. If we go from period 2 to period 3, at the end of period 2, our projected on hand is 700. But as we go through period 3, again, 300 more, we're down to 400. We're starting to get close to running out, especially as we move into period 4, which again is 300. However, and this is where lead time offsetting comes into play. We had a planned order release in period 2, but the lead time is 2 periods. So in period 4, we're going to, or at least we're planning to get 1,000 more. So the net effect in terms of projected on hand at the end of period 4 is going to be 1,100. We started out at the end of period 3 with 400. We're going to use or sell 300 a pair, which would leave us with 100, plus 1,000 equals that 1,100. The 1,000 is coming from the planned order receipt from the order that was placed 2 weeks ago on the Memphis DC. That's how this stuff works. Into period 5, we'll use another 300. That takes us down to 800. In period 6, we'll sell another 300, hopefully. We'll come down to 500. But again, we're starting to run out. So there's another planned order release of 1,000 that will come in 2 periods. And on the year goes. Hopefully, in this admittedly oversimplified example, we've been able to demonstrate the idea of where gross requirements come from, the importance of projected on hand, the role that cumulative lead time plays in getting goods to be in the right place at the right time, and especially this whole idea that demand signals from a satellite DC who places its orders on a regional DC in Memphis, who in turn gets its goods from a vendor in Cambodia. How does all of that information get into the hands of purchasing so they can manage these activities and make the proper adjustments? Because it should be very clear that it's very unlikely that this importer of footwear is going to sell 300 pair exactly in every period. Adjustments are going to have to be made. That is the essence of DRP and how it impacts purchasing. That's it for this section. Take a deep breath, We know this section had a lot of material in it. This module will continue on, and we will continue to understand the role of purchasing and global supply chain management.